All right, so today we're working on multi-area OSPF. In a previous video, which you can find right about here, we worked on single area OSPF. Now, single area OSPF and multi-area OSPF, they both have their pros and cons. In single area OSPF, we have the benefit of simplicity. We can take all of our routers, put them all into one area and call it a day. But when we try to scale that network up, it can be taxing on each respective router's resources. So for example, if we have a big topology like this, we have about 2, 4, 6 routers, and we have multiple interfaces in this single area. If something changes right here, each router is going to have to converge. It's going to trigger the SPF algorithm to run, and it's going to be taxing on the resources on the network. And when it finally converges, it's going to have to reflood LSAs and all of that, and it's going to generate a lot of traffic on the links, right? It's going to suck up a lot of bandwidth as well. So we solve that problem and scale our network by using multiple areas. Now, in single area OSPF, I probably mentioned this previously, you can use one area and name it whatever you want. It could be area 0, 1, 2, 3, area 51, area 69, whatever you want it to be, right? But in multi-area OSPF, you have the backbone, which is the transit area, called area 0, and it has to be area 0. All traffic flows through the transit area, and you're gonna have area 1 and then area 2 and then so on and so forth. Right here, this is where things get a little bit interesting. Right here we have this router connected out to the internet, right? The internet is not actually some nebulous cloud or what have you. The internet is just a bunch of other routers connected to one another. This router right here is called the ASBR, and it's simultaneously an area border router, an ABR, because it connects to multiple areas. It connects to area 2 and it connects to area 0, where all of the transit packet stuff is happening, all the action is happening. So this ASBR is essentially, I don't want to say defined by, but this becomes ASBR when we issue the default information originate command, which advertises the route to the internet to all other routers, right? So ASBR stands for Autonomous System Border or Boundary Router, right? I keep mixing them up. Autonomous System Border Router, right? And again, it's on the border of the organization and the border of the organization, autonomous system of our organization and another organization. So AS is simply an organization of routers. It's a company's network essentially, right? Just trying to define a few terms. So this is essentially how I learn. I've been working on this for the past 2 hours or so, learning the concepts, reviewing a few concepts, and now I'm gonna attempt to explain it to you guys, and you can feel free to follow along as well. But I have a few steps here that I'm going to go over. I already covered some of the steps, but essentially the first thing we want to do is understand the benefits of multi-area OSPF. The benefits are, when you run multi-area OSPF, it reduces processing cycles and memory on routers. How does it do that? It does it because now if you have this area right here and something changes with either one of these routers right here, it's not going to have to run as much cycles, CPU cycles, and it's not going to use up as much memory as if it was a single area OSPF router over here, for instance, right? So over here, if something changes with any one of these routers, then you're gonna have the issue of and convergence running on each router, right? An SPF algorithm calculation is gonna have to run on each router, and that can be cumbersome on a network. And then we also have the benefit of smaller routing tables because we can use route summarization to solicit less routes. And that happens when we have, multiple areas, right? So we can essentially configure, route summarization on this router to say, hey, yeah, look, I know about all of these areas right here, right? But these routers right here doesn't need to know about the 10.4, the 10.6, the 10.5, the 10.3 network, right? All it needs to know is that in order to get to over here at within any range, right, within a specific range of the 10.0.0.0 network, you can just send it to this router right here rather than taking up room in your routing table and having a route for each one of these networks, right? So let's say, for example, router 1. Router 1 does not need to have a route for the 10.2 network, the 10.3, the 10.4, the 10.5, the 10.6, because there's only a single path to each respective router, right? So that's another benefit, and that's what we're going to be configuring as well. We can configure the ASBR with the default information originate command, which is basically, again, going to advertise a default route to the internet, to every other router that is connected to, right? So what else? Yeah, we got smaller routing tables, and it reduces the frequency of SPF algorithmic calculations, right? So we went over all of that. We see the benefits of multi-area OSPF. Now we can get into the configuration of the multi-area OSPF, right? So first things first is we are going to configure each router for OSPF, and we're going to make sure that the loopback interfaces on ABR1 and ABR2 are in area 0, right? So let's do that. I did all of the configurations for the links between each, all of the subnets, as you can see. Did all of that because that would have been too boring to watch, right? So router OSPF 1, this is the process ID, and this process ID doesn't have to match amongst all of the routers. We can have separate unique process ID numbers across all routers in the OSPF network, but the same is not true for EIGRP. In EIGRP, each router has to have a unique, has to have a matching, not a unique, a matching ASN, right? So router 1, network 0.0.0.0, 255.255.255.255, area 0. Don't forget the area 0. I forget the area 0 sometimes. And you can run the passive interface command for any interface that's not connected to an OSPF router, right? So let's see. Let's check. Oops. Do show IP int brief. For the sake of this, I didn't configure any LAN facing interfaces, but ideally G0, let's do it, passive interface. I think is it int or just, yeah, I think I could just type int G01. Nope, I think I have to put, G01. And that essentially, it doesn't propagate any hellos out of that interface. That's a waste of memory, right? And we could do it for G02 as well. It's not going to propagate any hello messages out of that interface. It's a waste of resources, right? So we set up OSPF on router 1 by issuing the router OSPF 1 command. 1 is the process ID. And then we put the passive interfaces. We issued passive interface commands on G01 and G02. Now we could do the same thing over here. And I'm gonna see if I can go a little bit fast. Network O.O.O.O 255.255.255.255. Don't forget the area. Oh, it's not supposed to be area 0, it's supposed to be area 1. See, I'm already screwing up. So let's go back over here. I remember putting area 0. I'm so used to configuring. Yep. So let's just go ahead and let's put no in front of it and then put area 1. I don't want to take any chances. Right? No, and then let's put area 1. Oops. Put area 1. And then trying to be a little bit crafty. So now what I did was I put these routers interfaces into the same area, which is area 1. Now, what we have to do here is we're going to configure OSPF on this router. Router OSPF 2. Remember, they don't have to match. I'm just illustrating that right here. Network. We're gonna use, just to illustrate this point, 10.1.1.0 0.0.0.3. This is the wildcard mask for 255.255.255.252 or /30, right? And it's gonna be, that is going to be area 1, right? And then we're gonna do the same thing for the other interface, and it's gonna be in area 1. As you can see, the OSPF processes are starting up. It's gonna show another one in a second. Right? It says neighbor 1.1.1.1. That's router 1. It should be showing another one in a second. Yep, there we go. And now we're gonna do the same thing for this interface over here, right? So we became OSPF neighbors with router 1, with router 2, and then we're gonna become OSPF neighbors with this router over here now. And, oh, it's not area 1, it's gonna be area 0. Oops. 3. It's very easy to make a mistake. This is why I wanna learn automation, because it's very easy to put a typo in and then screw up your whole network. If we're lucky, we'll get through this lab without having to troubleshoot anything. So we've activated OSPF on all interfaces on this ABR, right? ABR1. Now we're gonna move on to this router right here. Let's get a nice little view of the topology. Conf T. Now we're gonna start up OSPF, and it could the number could be the same one as one of these over here. It doesn't matter what that process ID is. Network, it's going to be 10.3.1.0.0.0.3 area 0, and it's going to become neighbors with this router right here. They're going to form a neighbor relationship. And in the last video, I explained 8 reasons why an OSPF router won't form a neighbor relationship with another OSPF router. Right, so I just want to double check something. All right, so back to what we were doing. So we see that it, and maybe somewhere down the line, if you're interested, I'll go over the whole the states that each router traverses in order to get to full. and in what cases they won't be full, they won't get to a full state. What does that even mean, right? But let's move on. So now let's activate it on the other interfaces. Activate OSPF on the other interfaces. 6.1, and that's going to be area 2, right? So this interface right here is, this router right here is going to form a neighbor relationship with this router right here once I activate OSPF on this router, right? So that should be straight. But do we have any passive interfaces? We do, but I'm not even going to fool around with that right now. You know what the passive interface command does, right? It essentially doesn't allow propagation of hello messages out of that interface, which is typically a LAN facing interface. You don't need to do that because there's no router on the other end of that LAN facing interface. If there is, then obviously you wouldn't issue that, right? So now we're going to issue the default information originate. Did I spell that right? Originate, right? And now let's check do show IP protocols. See, we see that routing for networks over here. Maximum paths 4, right? Let's see. Right? So this gives us a lot of different information. So we could do show IP OSPF neighbors. Neighbor. We see that we're in a full state. We're in a full state with this DR router, the designated router, which is on the other end of the link. Right here. All right. So yeah, that's how we can verify it, right? Now, let me see something. Do show IP OSPF. All right. I like to play around with this. SPF algorithm executed 5 times. Yeah, this shows you a lot of good information. It is an area border router. It's not going to show, I believe it's not going to show the, it's an area border router. It's, since I don't have a, see, this is why I like to use my physical lab. If I was to use my physical lab and to do the same configuration of OSPF on my physical lab, maybe I'll do that one day and show you guys. Show you guys the whole concept of the ASBR stuff. It should show it in either one of these, but one of these commands. But since I'm using this little cloud over here, which is not actually a router, it probably won't show up as ASBR. But anyway, let's move on. So we're gonna activate OSPF on this right here. Router OSPF 1 does not matter. Net, and this is a nice command to use when all interfaces are in the same area. And area 2. Let me go back and make sure that I set this one correctly, because sometimes I forget. Yes, I have it in area 2. So now it's loaded. It's neighbors with this router right here. That's ABR2, so it worked. Let's double check over here. Yes, it formed a neighbor relationship with this router right here. And how do I know? I named it. I gave this a loopback, these two loopback interfaces numbers. So yeah, I need to go ahead and put those in area 0. Forgot about that. So let's do that right now. Net. How would I do that? I've never done that before. Net. It's gonna be 4.4.4.4. O.O.O.O. area 0. Right? I think that's it. Yeah. Because remember these zeros for the wildcard mask it's an exact match. So that's what we're gonna do. So we're gonna do that right here, and I believe this is 3. It's 3. Let me double check. Very easy to check. Let me just look through the Yep, 3. Right, that's how I checked real quick. I didn't want to run into any show configs. All right, so it's gonna be 3.3.3.3 O.O.O.O area 0. Right? Boom. So where are we now? Cool. Now we're gonna do the same thing over here. Not too much of a big deal. Conf T and router OSPF 1 network O.O.O.O 255.255.255.255. This again essentially means that every interface, it matches every interface in the on the router, right? So we got that taken care of. Again, we would run the passive interface on the necessary interfaces, on the LAN facing interfaces. Let me be quiet for a second so I could concentrate. Oops, see, I forgot. Area 2. Never leave the area 2 off, or the area off. All right, so hold on, let's see. Yep, form the neighborship. So they're all neighbors. Now let's look at these routing tables because they probably look crazy right now. So we can see these routing tables are insane. This router has a route for every single route, so every single subnet in the network, right? I mean, that's crazy. It's taking up a lot of memory in the router, right? So what we want to do is we're gonna set some summary routes. And bear with me because this is the first time, this is the first time I seriously set this command. So let's do it. So we're gonna issue an area 0. What we're gonna issue is these commands right here. Okay, let me click out of it. Area 0 range 10.0.0.0 255.0.0.0. That's essentially saying, hey, look, all of the routes that I'm getting from area 0, let's just advertise them as a 10.0.0.0/8 because we have one path to all of those networks. So let's first do it on ABR. Let's do it on ABR2 and see what happens. Area 0 range 10.0.0.0.0 255.0.0.0. Let's go ahead and do that. And it should take a little while to update, but let's see what happens. See, what it essentially did was it cleaned up the routing table. Because remember, before we had all of these routes. We had all of those routes, right? And it cleaned all of that up with just this route, this summarization, right? So that command said, hey, yeah, all of the routes that I'm learning from over here, yeah, just go ahead and summarize it. I wonder what would happen if you put area 2 in front of that. I don't know. Let's not mess with that right now. I don't want to. Let's keep it as clean as possible right now. And we're going to do the same thing here. We're going to say this syntax. Oh, why did I call this ABR2? Wait. Holy crap. Good thing I didn't notice that. I called this ABR2. This is ABR1. It doesn't matter. It's just a name. Area 0. The syntax is saying take all of the routes over here. Well, take all of the routes that's coming into area 0 and summarize it. Right? And when you do that, it should clean up the routing table. I should have showed you before and after, but we'll see the evidence of it anyway. Do show IP route. See, it cleaned it up. That's how you know you issued a summary route, right? Summarize it that way. And it's gonna show it right here too. Let's double check. So you gotta configure and verify. Configure and verify. You configure with the necessary commands and you verify with the show commands. See, 10.0.0 variably subnetted, and it summarized it. So every route, like say it needs to send, say router 1 needs to send a packet over to router 5. It doesn't need to have this route in its routing table. It just needs to know that it can send it right here to this router and it's summarized through that router. It's a summarized route, right? They'll handle everything else. Right? It has all of the routes. See, 10.0.0.0, 10.0.0.0/8 is a summary, and it shows all of the routes here. Well, it's a summary, so it's not even showing all of the routes. Well, is it? I think it is. Yeah, it's showing all of the routes. It has all of the routes. So wherever it needs to go, it sends it according to this routing table, right? And I would say if you're a CCNA or you're studying for the CCNA, get real familiar with the routing table because it's essential. So see, this has all of the routes. So now this router right here, four, five, six. Yep, this is summarized too. It doesn't have 1 and 2. So that's essentially it. I'm still perfecting or learning. It's never going to be perfect, but I'm still learning the essentials of OSPF. There's so much to learn with OSPF, but that's basic, right? So multi-area OSPF, when you scale the network up and you have a larger network with a bunch of routes in them, it's definitely beneficial to use multi-area OSPF and route summarization. And yeah, that's pretty much it. That was multi-area OSPF, a very simple configuration, and that was fun. I got to really watch how everything plays out in real time because I've never used the route summarization command before. I was just reading up on it, learning up on it, and then since I understood the concept of route summarization and I understood what it does, what it means, what we're using it for, I could just, use the command and then just issue it. And then, that's pretty much how I learned. I learned by doing, and if I make a mistake, then it's very hard for me to forget. So that's why I highly recommend that you guys do what I'm doing. Create labs and just randomly throw things at the wall to see what sticks, and then go back to the textbook and see what works for you, right? So if you enjoyed this video and you want to see more like it, click right here, and I will talk to you guys next time.